Hey everyone. I kind of wanted to explain a couple of things, I guess, for the lesson, so there wasn't as many questions too if I went through it. I am going to go over algebra stuff first, and then I'm going to get into pre-algebra later. So if you're here for pre-algebra, if you want to come back in like an hour or so, maybe 30 minutes, it just depends on how long or how many questions I have, if any. So I know this is kind of impromptu. I was originally planning to do it on Wednesday because of the holiday, but I'm going to go ahead and go over some stuff now because I just had so many questions. So every week you're going to get something similar to this, whether it's a lesson plan basically for the week, and it's going to give you the overview, educational standards, and then the learning topics that we're going over. Especially the part one is going to be kind of like your review of stuff we've already done, and then the part two is like the new extended stuff that we're going to be talking over. It's and then any materials that you need is going to be here. The nice thing about everything with all the blue, they're hyperlinks, so you can literally click on each file, and it'll bring you there. Sometimes there will be paper copies. For example, the guided practice here. If we click this, it's going to take us to the guided practice with the key, and then the independent practice is going to be this PDF. Sometimes you could turn it in just by writing it on the document and then sending it to me. You could also, sometimes there will be a Google form, or there will be a quizzes form that if you have internet, you can put it in there. So please pay attention to the links underneath the lesson plan, and then the new stuff will be the part two, the expansion on new material. And there'll be videos already set up. That stuff will be out on Monday. I still was planning on doing the streams. The schedule, like I said on my last post, is going to be a little wonky for this week just because there's some other things that need to be established. And then once that gets better, I promise that I'll have more of a succinct, more set in stone. I'll use that word, just that phrase instead. Schedule, which I will still post. So I know there's a schedule in the bottom right hand corner right now. We can use that one for this week, but it may be different than what's already there, like I said. So this part two stuff is going to be all of the additional new material. You'll have some videos that either myself or Miss King has found or created, and then the notes. The notes will pretty much just be the key. And then you'll have your guided practice and then your independent practice. Independent practice is the stuff you're going to be turning in. I know it's pretty wordy for this, but just read it carefully. You have the whole week to do it. There's not going to be any other new material, so each subject's going to have 1 week of material. So just kind of, if you still have your agenda, have that out. Have some sticky notes in place so you know which ones need to be due. To submit, I still recommend doing all of it, but I just like that way you know which one you need to turn in and which one you don't. And then the mastery check, that will either be PDF, but if you have internet, like I said, I've posted that. That'll be usually the second or third thing in that assignment. You can just put it in to the Google form. You do not have to do it twice if you have internet. If you don't have internet, that's kind of why the PDFs are there. They're same type of situation. So if you, and then for like the guided practice, there are two things. It's you can do this, which is usually the IXL or Khan Academy. So for the example, if I clicked on this link, this is that would take me to Khan Academy right now. This is just placed in here, so I can't. None of the links are going to work. And then, or you could do 1 through 15 odd, and then there's a key for it to kind of help you with that if you have questions. And then there's some optional stuff, and there's also some enrichment activities below as well. So if you finish all this and you want some more work, or more practice with it, I should say, better yet, there's some Khan Academy or IXL links. There's you can do a few more problems in there. You could ask me for more problems that I can help you with, because I want to make sure that when you take this last thing, the mastery check, that you are good to go, that you understand the material, because this is going to be stuff you're going to see again, especially in Algebra 2. So what I'm going to do now is that I am going to I was going to go over the notes. So I was going to go through them again. I don't know if that's going to be helpful with having the audio version of it rather than just the copy of the key or what was already up there. So just get a few things into play because Some stuff is out of. And feel free to ask questions because other people may have questions like you did about the material, and they can see it later if they go back to review it. I am just gonna get this set up. And if you are here and you would rather me stop than going over the notes and just do practice problems, I can do that as well. I have the guided practice on this form as well, so we can go over a few of those as well. And I planned about an hour over this, so I'm not gonna waste any time. I'm going to kind of move through this. So if you have questions, make sure you ask. I'll check every once in a while as we go over this. So a monomial is an expression that is a number or variable or a product of a number and one or more variables. We also refer to that as like a term. And I gave some examples on that key, so I'm going to write that real quick. So that's an expression. So number, comma, a variable. Or product of number, and I'm just going to do just a variable just right now. It could be more than one variable, but we'll just write it for that right now. You also knew that as a term, which I'll write up here. So we also call that a term. And then I gave some examples. I mean, just any number in general, we could just use 5. For a number, for a variable, we can use something like y, v, b, any of the letters of the alphabet. And then if it was a product of a number or a variable, we have something like 6x, or if it was more than one variable, we can have 7 y, b, something of that nature. Or if we had the same variable twice multiplying, you could also have something like 8x, and what is that going to equal? That's just going to be 8x squared, so that's another one. Okay, I'm just showing why, but yeah, this is another one that we can deal with, so 8x squared. And then the degree of a monomial is going to be the sum of its exponent. The sum of the exponents of its variables. So the sum of the exponents of its variables. So if I have something like, well, I'm just going to use the example up here. If I just use 5, does that have a variable? Well, it has a variable, but it's not present right there. So it's actually going to be a degree of 0, because if there's no variable there, that means then it's raised to the 0 power, because anything to the 0 power is 1. So that's just 5 times 1, so just 5. So that means you have a degree of 0. That's why that's like that. And then if we have something like y, the exponent is going to be to the first power. So that means then our degree is going to be 1. And then if we have something like y squared, then that's going to be to a degree of 2. But if we have a product of variables, so something like how I had up here was 7yb, so yb, that would be a degree of 2, because y has an exponent value of 1 and b has an exponent value of 1, and when you add those two exponents together, you get 2. So something also like x cubed y second z 7 would be a really high degree of 10, 12. And then a polynomial is going to be a monomial, or the sum or difference of 2 or more monomials. Let's write that real quick. And if you would rather me just go straight into practice problems, I can do that, but I felt like going through the notes may help a little bit, just so you had some audio with it rather than just reading it. So a polynomial is a monomial or the sum or difference of two or more monomials. So an example would be something like 4x squared y. You could have had something like, let's do 2y squared plus 3y minus 1. There was also another one on there where I had two different ones, so I had something like 5y cubed minus 4y plus 2. That's another example as well. And then in standard form of the polynomial, that's going to be when the degree of the monomial terms decrease from left to right. So something like this, it's already in standard form because we have y squared, y, and then we have y to the 0 power. So that's already in standard form. But I'm going to give you an example if it was not in standard form and how you would reorder that. So in standard form of a polynomial, it's the degree of the monomial terms decrease from left to right. So if we had an example of that, I'm going to write this in purple, so it's just a different color. So example, let's do 3x minus 2x squared plus 5x cubed minus 1. So right now, our highest degree is not in the front, which our highest degree would be x cubed, so our degree of 3 up here. So 5x cubed would be first, followed by our next highest degree, which would be x squared, so minus 2x squared, followed by positive 3x minus 1. So this would be in standard form because our degrees are decreasing from left to right, going from greatest to least. And the degree of the polynomial you will identify as the highest degree. So it's the degree with the greatest exponent. So this is going to be the degree of a polynomial is the degree of the monomial with the greatest exponent. So in our example, is the greatest. So if I was looking at the example right above in purple, our greatest degree value was 3. So that means then our degree for that polynomial is going to be 3. So wow, that was a terrible D. That is going to be a degree of 3 based off our last example. So that helps us with identifying degrees of polynomials. Whoops. So now we also have to identify, though, based off the number of terms. So we have a monomial, and then we have a binomial. So binomial, think of like a bicycle. A bicycle has two wheels, so this is going to be a polynomial with two terms. So a binomial is a polynomial. That should have been closer. Polynomial with the W with the slash means with two terms. And if I'm moving too fast, just let me know. With two terms. So an example of that would be something like a linear equation. Like if we were dealing with something like, you can think of like 2x plus 1. This doesn't have to be, though, with a degree value of 1. This could also be a something like 3x squared plus 4. That could have been a binomial as well. And then if we move one more up, we add another monomial to the polynomial, we would get something like a trinomial, which, thinking of like a tricycle, so 3, we have 3 terms, so a polynomial with 3 terms. So you could have something like 4x to the 4th plus 3x minus 2. We have 3 terms here, so we have, this would be a trinomial. And then I'm going to Alright, so we're done with that page, so I'm going to move over just to the next page real quick. Let's write with this. Alright, so I know this one was a little bit trickier to see since the it was already shaded in on the paper, so hopefully it was easy to be seen with the color that I wrote over it. So they wanted you to find the degree of each monomial. So with this, I didn't explain that one, I just realized. So with 18, does it have a variable? Well, technically it does. If our variable was there, it would be, let's just give it any letter right now, we'll make it an x. It would be x to the 0 power because it needs to be 1. 18 times 1, so this is a degree value of 0. So the degree of a non-zero constant is always going to be 0. And the reason for that, because remember, anything raised to the 0 power is 1. 18 times 1 is just going to give us 18. Now for our next one, we have 3x y cubed. So I'm not going to put in the degree yet. We have 2 exponents, and the exponents on our variables are 1, which is on the x, and 3, which is on the y, so it's y cubed. So if we add those together, you're going to get 4. So because our sum is 4, that means then we have a degree of 4. Alright, next one for C, 6C, we have a degree value of 1 because the exponent value is to the first power. And I'm now realizing that on the notes key, I don't think I've explained this one. So it says, what is the degree of 9x to the 0? And they wanted us to answer that, and that would be, well, we kind of just discussed that with A. We'd have a degree of 0 because the exponent value is 0. And it would just be, and if we were to write that simplified, that'd be 9 times 1, because anything to 0 power is 1, so it would just be 9, and we know that our constants, our non-zero constants, is just going to have a degree value of 0, so our degree would be 0. And I'll put a slash through that. That's another way to show 0, just in case people don't think that's an O. So instead of having to say degree 4, degree of 0, degree of 1, we can come up with other excuse me, terms to classify these degrees. So starting from least to greatest, starting with a 0, that's going to be a degree of 0, that's going to be a constant. We kind of remember that when we're doing multi-step equations, that always the ones that didn't have the variable that was deemed our constant because it wasn't changing. You could also think of that as because like there's no variable to cause an effect to it, so that number was not going to change. Linear, you can think of our linear lines. So that's when you have a degree value of 1. So going back to our linear equations like slope-intercept form, so like 4x plus 3, we would have a linear, it's a linear line, and then when we get to a degree value of 2, we call those quadratics, which we're going to get into later this year. And then if you have a degree value of 3, that's a cubic. And then anything beyond that, you use the number. So a 4th degree, 5th degree, 6th degree, 7th degree, and so on and so forth. In terms of degrees. So anything beyond 4, you're just going to use the number, or 4 and beyond. And same thing with degrees, we also have classifications based off of our terms. So if we have one term, that was our monomial. If we have 2 terms, that's when we have our binomial. And then when we have our 3rd term, that's when we have a trinomial. And then anything beyond that, we usually use polynomial with 4 terms, polynomial with 5 terms. So you just use, again, the number of terms that are already in there if you have it any more than 3. So I'm going to scoot this to the next page. So if we were to practice with this, and if I'm moving too fast and you have questions, just let me know. So if we were to practice doing this, and I know you already have the answers because they already posted everything, they gave you all the keys, so I'm just going to kind of go through this a little quick and then we'll do some practice ones together. But so if I was to write each polynomial, first of all, in standard form, combine like terms, then name each polynomial by its degree and the number of terms. So looking at A, we have a constant value, and then we have a monomial here that has a degree of 1, so that we have to reorder this. So the correct form would be 7x minus 2. Now we have to label it based off the degree and then the number of terms. So degree first. Going back to that chart, so hopefully you have that in front of you. So we have a degree of 1, and I'm going to try to write this as small as possible. So a degree of 1, so that means then it is linear. And then for the number of terms, we have 2. So having 2 terms makes it a binomial. So we just put those together and we get a linear binomial. That was a terrible box, but so that would be your answer for the for A. So for B, let's go ahead and put it in standard form first, combining our like terms. So we have 3x to the 5th and we have negative 2x to the 5th. So if we combine those, 3 minus 2 is going to give us 1x to the 5th plus 7x. That's our next term, so I'm going to double underline that. And then triple underline our last term. So minus 2. So what is our degree? So looking at our degree, we have a degree of 5. So anything 4 or more, we just use the number. So this is a 5th degree. And then the number of terms. We have 1, 2, 3 once it's simplified. So this is a 5th degree 3-term polynomial. And a 3-term polynomial is going to be a trinomial. So 5th degree trinomial would be the answer for B. All right, C. We don't have to combine anything. We're just going to have to reorder it. So putting our highest degree first, we get -9 x to the 4th plus 6x squared plus 7 in the correct order. So our highest degree is 4. So it's going to be a 4th degree. And then again, how many terms? We have 3, so this is pretty much just like the last one anyway. The degree is different, so it's a 4th degree trinomial. And that's how we got the answer for C. All right, going to D. We have 3 terms right now. Doesn't look like we can combine anything, but we do need to reorder it. So highest degree first would be -y to the cubed plus 3y minus 4. And looking at our highest degree was 3, so this is when we're going to use one of those fancy words, and the 3rd degree is going to be a cubic polynomial, so 3 terms means it's cubic. And we have 3 terms, so it's going to be a cubic trinomial. And then with the last one, we have a 7v and a -11v that we can combine. So -11 plus 7 or 7 minus 11 would give us -4v plus 8. So this would be the simplified standard form. Our degree value is 1. So that means then it is a linear polynomial. And to be more specific, the type of polynomial it is, it has 2 terms. So since it has 2 terms, that means it's a linear binomial. So hopefully putting it in standard form and labeling has helped you out. Excuse me. A little bit with that. So now we're going to go to adding and subtracting. Adding and subtracting is kind of like combining like terms. The only difference is that now you're having to deal with degrees. And because you're having to deal with degrees, you have to understand that you have 9 like terms that have the same degree value. It's the same thing like as if you were going to do volume and surface area. You're not going to combine volume and surface area together. They're different types of situations. Okay, so let me just scroll down a little bit. So when adding your polynomials, you're going to group your like terms and simplify. So group like terms and simplify. And once you've would have been a little bit of a lag there. Once you group them, then you're just going to simplify. So for example, on the first one, see one thing. I think there was a little bit of anyway, so for the first one, we have 7y minus 7x plus 15a plus 3y plus 8x minus 8a. So if I dropped all these parentheses, we would just be adding them like normal terms. So dropping them, I have a 9y. Let's highlight instead. So I got 9y and a 3y. So if I combine 9y plus 3y, I would get 12y. I have -7x and 8x, positive 8x, so if I added those together, -7 plus 8 would give me just 1, so 1x, and we always just write a single variable is just the variable, so plus x, And then last, we have 15a, what's a rough way to do that? Minus 8a. So 15 minus 8 is going to give us positive 7a. Okay, and I know I broke that down a little bit different on the note key, so I grouped them all together instead of using the highlighter tool, and I think that hopefully this helps. If it doesn't, I guess write it the other way that I had it up there before with separating it, which I'll do on the next one. So our final answer would be 12y plus x plus 7a. So on the next one, we're going to combine our like terms. So a squared, I don't have another a squared, so 3a squared plus 3ab. So plus 3ab, then we have a positive 4ab, so then we have negative b squared and a positive 6b squared, so negative b squared plus 6b squared. So then combine our like term, they're already grouped together, so 3 plus 4 is going to be 7. And I've already given away the hint for the next one, but it is going to be positive, but negative b squared plus 6b squared is just going to be 5b squared. And that'd be our final answer, so I'm going to write that up. So that would be your final answer. Alright, so that's with adding on this page. Let me move over. A couple more and then we're going to get into subtraction. Subtraction is just a little different, not a whole lot, but okay, so I'm going to speed this up just a little bit just because I'm not going to rewrite them, but if you need to help with rewriting them, that's fine for you to group it that way. I think as we get used to this more and more, we'll be able to move a little bit quicker to it. So add things together that are like terms. So we have 6x squared and 2x squared. They're adding together, so 6 plus 2, because it's a positive, is going to be 8x squared. 3x minus 6x. So 3 minus 6 is going to be negative 3x. 7 minus 4 is going to be positive 3. So that would be your answer for number 3. And then for number 4, we have 4t squared plus 3t squared, so 4 plus 3 is going to be 7t squared. And then we have negative 6 and positive 11, so negative 6 plus positive 11 is going to be a positive 5. So that would be our final answer. And if you have questions, please feel free to ask in the chat. And then if there's anything that's confusing and you don't want to ask it in the chat, you can just email me later. Okay, last one. 3p cubed, 9p cubed, so we add those two together because they're both positive, so that's going to be 11p cubed. Positive 6p squared plus 11p squared is going to be a positive 17p squared. And then positive 10p plus 3p okay, awesome. I'm going to go over the guided practice in a minute. I'm going to finish up on this, and then I can go back over degree stuff too as we're doing it. In fact, I should have done that on this one. We can go through that real quick with these 3 problems, and I'll write those to the right. So positive 10p plus 3p is going to be 13p. So you would combine them again, just like terms. Let me see if y'all can see the whole thing. Okay, you can. Okay, so a couple things. Let's go through the naming piece. So when you're naming, you're going to name off the degree first. So what's the highest degree that we're dealing with? And with degrees you have 0, which is a constant. So think of just a regular integer. So like 8 would just be a constant. There's no variable. Well, there is a variable, but it's to the 0 power. If so, let me write this down up here, over here. So you have 0 for your degree. And I know this is already in the notes, but you have your degree, so that's a constant. You have a degree of 1, so that's a linear, so think of like a linear line. So like 4x plus 3, you know, that was a constant line, that was a linear line that we were dealing with. Then we're getting to quadratic, and I'm going to spell this terribly, but I usually, when I was in school, I just do quad, and then 3 would be cubic. Should just go ahead and spell quadratic. And then past that, it's just the number. So I'm going to do 4 plus. So 4 and beyond, you'll just use the number of that's the degree. So for example, if we had 4, it'd be a 4th degree. So 4th degree, 5th degree, 6th degree, 7th degree, 8th degree, 9th degree, all the way up for infinity. I mean, I don't think you'll ever be dealing with anything really more than 5th degree, at least that I can think of right now. You'll have to be naming it, but if we had to, that's what you would use. So for anything 4 or more, you just use the number, degree. And then after that, you're going to label it as the number of terms. And that's where the prefixes come into example. That will help you out with things. So if there's only one term, mono, so that's a monomial. 2 is going to be a binomial. So you can think of nomial. You can think of like a bicycle. 3 is going to be a trinomial. So think of like a tricycle. And then 4 or more, that's again, so anything 4 or more, you're going to be dealing with, so a 4-term polynomial, 5-term polynomial, 6-term and beyond. So it's just, it'd be the number of terms polynomial if you have anything 4 or more. So for example, with this number 3, if we were to label this, we're going to look at our degree first. Our degree is 2. That's our highest exponent value. So looking at what I wrote down, we have a quadratic then. So this is going to be a quadratic. This underneath in orange, this is going to be a quadratic. So quadratic, and then how many terms does it have? So we have 1, 2, 3 terms. So this would be a quadratic trinomial. So that's how you would name the number 3. I didn't ask you all to name it, but it just kind of as a review as we were doing this, because this is something new. For number 4, again, go off the degree. So our highest degree is going to be a degree of 2 after you've written it in standard form, which is now in standard form. So a degree of 2 again is going to be a quadratic. And then how many terms? Yes, so the exponent determines the term. No, I'm sorry. The exponent determines the degree classification. The term classification comes off of how many terms there are. So with number 4, and I'm sorry if there's a delay in me answering the question. So with number 3, you have 1 term, 2 terms, 3 terms. For the number 4, you have 1 term, 2 terms that are being combined together. So the degree is going to be the highest number on the highest exponent value. And then the number of terms is going to be how many terms you have there. That's going to be the second word that you're dealing with. So for example, in number 4, the degree value was 2 because it was t squared. There wasn't any other variables attached to this. So then that would be a quadratic binomial because there was 2 terms in this polynomial. for the next one, again, looking at the highest degree, so look at the highest exponent value. That's going to be an exponent value of 3. So this would be a cubic. And then how many terms do we have? We had 1, 2, 3 terms. So that's going to be a cubic trinomial. And what I'll do is I'll label the last 3 on this next one coming up for subtraction too, so we can keep practicing with the naming. All right, I'm gonna scroll down a little bit to subtraction. Now, when I was trying to find some videos for y'all, because I was still planning on doing the stream with it, I did see some other videos that other teachers have done different things with doing the subtraction, and I think the best thing to do is to invert them all, and then add them together, kind of like adding the opposite. Now, I have seen, if y'all are looking out there yourselves, there's also where they stack them on top of each other, and that can sometimes help. I'm going to stick with simply just adding the opposite for right now, just at least on the first go through with it. And I can show you another way to do this, but again, I feel like adding the opposite's a little bit easier. That way you don't get confused with the signs. The stack method is kind of like going back to system of equations when we were eliminating. So that may look familiar when we do that, but I'm going to just fill this stuff in real quick, doing it by adding the opposite. And I'm not going to rewrite everything that was on the notes because the first thing I told you was to rewrite. So I wrote this and then I rewrote this as adding. Because I'm doing this live, I can do this a little bit easier so I can show you what I'm doing. So I'm going to add the opposite. So I'm going to make this a plus. And then the opposite of a negative is going to be a positive. This is just going to be a negative. And this is now going to be a positive. So that's me rewriting it just kind of quick using the board, and then we're just going to group up and simplify. So we have 9y and 3y, so we add those together. That makes that then 12y. You have a negative 7x and now a negative 8x, so that's going to be a negative 15x. And then you have a positive 15a and a positive 8a. So if you add those two together, 15 plus 8 is going to be 23a. And we'll go ahead and actually name this one because this is kind of a funny one to name. So this is actually already in standard form because the degrees are all the same. So what is the degree value? Well, y has a degree value of 1, x has a degree value of 1, a has a degree value of 1. So we have a degree overall for this problem is going to be 1. So that is a linear polynomial. And then how many terms do we have? So we have 1 term, 2 terms, 3 terms. So it's a linear trinomial. Okay, so that's how you would label it. Now, like I said, I will show how to do the stack method. Again, I would prefer you adding the opposite, but if you want another way to do this to help you out, that's okay as well. So what you're going to do is you're going to kind of set them up just like with system of equations. So I'm going to erase this real quick. Actually, no, I don't need to erase that. I'm going to write the first term, the first setup there, and then I'm going to do the stack method over here. So I got 9y minus 7x plus 15a minus, and the important thing when you're stacking is that the terms need to match up, as in you're already grouping them together. So this was a negative 3y. This was a positive 8x, and a negative 8a. And I forgot the a on there, I'm sorry. So notice again, a's are matched up, x's are matched up, y's are matched up. So they're all together nicely. They're all stacked on top of each other. If you had something that didn't match up, like if there was something missing, that we would just put a 0 there, because there wasn't one in one of those terms, but I think I can show that on a different one. So I'll at least do this at least one other time to show you if there had not been a term that matches up. So then you're just going to subtract like normal, as if you were subtracting. So 9y minus negative 3y, so you'd be adding this point, you would still get 12y. Negative 7 minus 8, so negative 15x. 15 minus negative 8, so you're adding 8, so that's going to be a positive 23. So there is the possibility of messing up with not switching the signs, so just make sure you're careful when you set this up like this. So I think it's a little bit better to do adding the opposite, but that's just me. Alright, I'm going to scroll to the next page. I think it's the last one. Okay. And then I do have the guided practice on here as well. Let's scroll down. Alright. So I'm going to do adding the opposite for this one. I'm not going to do the stack method on this one. I'll do the stack method on the number 9, because that's a good one to show that with, where there's something that's missing. Okay, so adding the opposite, I'm going to just change the signs real quick. So this negative becomes a positive, negative 2a, and then minus 6b. So group them up. 5a minus 2a minus 3b minus 6b. So 5 minus 2 is going to be 3a. Negative 3 minus 6 is going to be negative 9b. And that's our answer. If we were to label this, again, this would be a degree of 1, so that's a linear polynomial. And there's only 2 terms, so it's going to be a linear binomial. So on, oh, wrong thing. Move this. Alright, so again, I'm going to just change the signs real quick because this one we're actually adding. Whoops, so I almost made a mistake. So we're just adding, you're just going to group up together. So 5a plus 2a minus 3b plus 6b. So 5a plus 2a is going to be 7a. Negative 3b plus 6b is going to be positive 3b. And that would be our solution for number 8. And if you were to label that, again, we have a degree of 1. So it's going to be a kind of gave that one away. It's a linear binomial. And that's why I'm going to try to stream as much as possible. And I'm really sorry I don't have a set schedule right now. Alright, this one again, I'm going to add the opposite, and then I'm going to stack it, just to show you the 2 different methods to see if that helps. Again, if you would rather just add the opposite, I think it's a little bit better. I know it's a little bit more work, but you're going to get to the point that you don't even need to group it out like how I'm grouping it out. You could just do it in your head, and then with the stacking, there's the potential of making a mistake, and I don't want that to happen. Okay, so subtraction, we're going to add the opposite, so minus, plus. Okay, that's a terrible plus. All right. So 2x cubed minus 5x cubed. So these terms are grouped together. We got a positive 4x squared. I don't have an x squared in this next polynomial over here, so I'm going to then just move over to the next degree. So I don't have an x value, so I'm just going to do minus 2x, minus 6 plus 2. Now you just simplify. 2 minus 5 is going to be negative 3x cubed plus 4x squared minus 2x. Because again, these didn't have anything to combine, and you cannot combine them together. They have different degrees. So negative 6 plus 2 is going to be negative 4. That would be our answer. And if you were to label this, the highest degree, looking at the degree, looking at the degree, your highest degree is going to be 3. So that's going to be a cubic. And then looking at the number of terms, you have 1, 2, 3, 4 terms. So that's a cubic 4-term or fourth term. Yeah, 4-term polynomial. So that's how you would label that one. Now, this next part you can skip if you like the adding the opposite, but again, I'm still going to show how you can do the stack method with this, just in case you would prefer to have that as an option. So again, it's kind of like elimination for system of equations. So I'm going to write my first one, 2x cubed plus 4x squared. I'm then going to write plus 0x. Okay, I know we do not have an x in this one, but if we don't have any, how many do we have? We have 0. So it's kind of being used as a placeholder. Now, if you don't want to write the variable, that's fine. I just would, so you can see that your degrees are decreasing. If you'd just rather make it 0, that's fine as well. I just think it helps just so you don't get confused in trying to combine 0 with 6. That's why I did 0x, because these aren't combining. Then I'm going to do minus 5x cubed. I do not have an x squared term, so I write 0x squared plus 2x, and then minus 2. So 2x cubed minus 5x cubed is going to be negative 3x cubed. 4x squared minus 0x squared is just going to be 4x squared. 0x minus 2x is going to be negative 2x. And then negative 6 minus negative 2, so that's plus 2. So negative 6 plus 2 is going to be negative 4. And did we get the same answer? We did. So that's another way you can do it. Again, I would recommend more of the adding the opposite, but if this way seems to make more sense, that's fine. Just please don't forget about your placeholders, and don't forget to change the sign along as you're going. That negative goes along to each term, not just the first one, because that would be a common mistake when we were eliminating, when we were doing elimination with system of equations. I'm going to scroll down to this last two. I'm going to add the opposite on both of these, so I'm going to change these signs real quick. So I got v cubed plus 6v squared minus v minus, so we're going to make this a plus, negative 9v plus 7v squared minus 3v. So combine your like terms, you have v cubed minus 9v cubed plus 6v squared plus 7v squared minus v minus 3v. Now we're just going to combine them together. So v cubed minus 9v cubed is going to be negative 8v cubed. 6v squared plus 7v squared is going to be 13v squared. And then negative v minus 3v is going to be negative 4v. Alright, so if we were to label that, again, looking at the highest degree, that's going to be a degree of 3, so that's going to be a cubic polynomial, and we have 3 terms, so it's going to be a cubic trinomial. So this would be your answer, and this is if you would have to label it. All right, last one. We have 4x squared plus 5x plus 1 minus um, hello Aiden, 4x squared plus 5x plus 1 minus 6x squared plus x plus 8. So I'm going to add the opposite. So boop, minus, minus, minus. So that was an easy one for us to do. We just had to change the sign for all of them. So 4x squared minus 6x squared. I'm going to loop those together. Again, you do not have to group them up each time like I'm doing it. I'm just doing it to show you what's going on. If you can do this in your head real quick, you can get to the point you don't have to write out all the time. Like you won't have to keep doing it over and over again. So 4x squared minus 6x squared plus 5x minus x plus 1 minus 8. So 4x minus 6x, I'm sorry, 4x squared minus 6x squared is going to be negative 2x squared. Positive 5x minus x is going to be positive 4x. And then 1 minus 8 is going to be negative 7. And that would be your answer for this, but I do want to label it. So just give me 1 second. To just get this moved out of the way. Just bear with me just for a moment. Okay, so highest degree is going to be 2. So that's going to be a quadratic. And we have 3 terms, so that's going to be a quadratic trinomial. And that's what you would do if you label it. So hopefully that made sense. Sorry, looking at the chat now. I've been alright. I've been missing y'all a lot because it's not the same doing it from home. So hopefully this is helping some. Some of y'all's emails have been absolutely ridiculous. Made me laugh a couple times, but it's just good. Hopefully you're doing okay as yourself. So I was planning on doing a few practice problems to help y'all out. If that sounds good. I don't know how many people are in here right now. Check. Alright, so I was gonna do some practice problems. Does that sound good to y'all? Hopefully it does. No, it's just math, but I figure while I'm here. Oh, that's not good that you broke your board. What were you doing? I'm sorry, bud. That's not good. So you must be going stir crazy right now with no board. You got your tech deck though, right? You can use your tech deck to hold you over until you get your next board. Yeah, I'm gonna do a couple practice problems. Alright. These are a lot of addition. I don't know which ones I gave y'all, so the guide to practice, just as a reminder, isn't turned in because you already have the key. So I'm gonna go over a couple. Ooh, did you hurt yourself? I'm gonna go over a couple of these, and then I'm probably just gonna go back and forth because they do addition and subtraction, back and forth. So unless there's one specifically you want me to do, I can do that as well. Is there any with 3 terms? Because I kind of would like to do one with 3 terms. No, it's only 2. Oh no, there is. Okay, I'm definitely gonna do at least one at the end. So between 27 and 30, I'll probably pick one to do as well, but I'll stick with the 2 terms for right now. And if you're here for pre-algebra, I'm going to start that probably within the next 15 to 20 minutes, and I'll do volume of that. And then with algebra, I will do more tomorrow. I don't want you to think that I'm just giving up on y'all right now. It's just So like this is going to be going on. What is today? What's today? Tuesday? I'll do another one tomorrow. Probably not as long because like I said, I'm going to try to do some office hours type of situation where you can ask individual questions, and then I'll probably do another lengthier stream on Thursday. So for the first one, like terms, 5p squared, negative 3. 2p squared, negative 3p cubed. Okay, so our highest degree is going to be this 3p cubed, I'm sorry. So that's going to come first, and there isn't another one to combine, so that's going to be negative 3p cubed. Our next degree of 2, 5p squared, 2p squared, and we're adding, so 5 plus 2 is going to be positive 7p squared. We don't have a singular or a p value of p with a degree of 1, but we have a constant, which is going to be negative 3. So if I was to write that out, then finally, that would be our answer. So hopefully that first one made sense. I'm going to pause for just a second to get some water. Alright, so next one, you're just going to be adding the opposite. Again, if you'd rather do the stack method, I'm okay with that. I'm probably just going to be sticking with adding the opposite though, just to make it a little bit easier. Or at least to be more consistent. So I'm going to make this a plus, make this a minus, and then the opposite of a negative is going to be then a positive. So a cubed plus, they're both positive, so it's going to be a cubed plus 4a cubed, negative 2a squared, negative 3a squared. So then just simplify. A cubed plus 4a cubed is going to be 5a cubed. Negative 2a squared minus 3a squared is going to be negative 5a squared. So that would be your final answer for that. I'm going to scroll down. Does anybody want me to do any more between 1? I mean, I did 1 and 2, but does anybody want me to do any between up to 8? I was going to start with 9 and 10 next. If I don't hear any complaints about not doing any of those, then I'm going to just stick with 9. Alright, I'm going to go to 9. Whoops, wrong thing. And if you want me to go back, I can go back later in just a minute. Oh, number 6. Alright, okay. Add the opposite. Yikes. Plus, minus, plus, I just reverse the signs. 4r cubed. Oh, whoops, I just made a mistake too. Then you also have 3r to the 4th and then negative r to the 4th. So your degree of 4 is going to come first. Come on now. So 3r to the 4th minus r to the 4th. Then you have your cubed, so that's going to be plus 4r cubed plus 5r cubed. Then you're going to combine your like terms. 3r cubed, I'm sorry, to the 4th minus r to the 4th is going to be 2r to the 4th. 4r cubed plus 5r cubed is going to be plus 9r cubed. So that would be your final answer for that. And that would be a 4th degree binomial. So if you wanted to label that, that would be a 4th degree I did not ask you to label, so you do not have to do this. 4th degree binomial. scoot down to number 9. Alright, so number 9, this one's going to have then 3 terms in each of the polynomials. Oh, you know what? I just realized something because I didn't scroll over to look at what exactly is going on. I don't think you can see that because where the chat is. So hopefully that makes that better. I'm sorry, I should have checked that first. So then on the number 9, I'm gonna get my pen. We're just adding, so I don't have to change the sign on these. So we're just gonna combine our like terms. So we have negative 4k to the 4th, negative 3k to the 4th. I'm just gonna add those real quick. So negative 4 plus negative 3 is gonna be negative 7. K to the 4th. I don't have a k to the 3rd. So looking at each term, I do have a k to the 2nd, k to the 2nd. So 3 minus 14 is going to be negative 11 k to the 2nd. Positive 14 minus 8 is going to be a positive, what is that? It's 2, 6. So that would be your answer for that one. And I know I'm kind of going a little quick on those because doing the quick maths with that, but you can use your calculator. So even if you're doing this early in the morning or late at night and you kind of had a lapse in memory on what to do, you can still use a calculator. There's no judgment there for doing that. All right, I'm gonna do number 10 because it's a subtraction, and then I'll probably do number, let's see real quick while I'm down here. Is there one with both? Yes, I'm gonna do number 30 because there's both addition and subtraction there, and I think that would be a good one. Okay, so 10, then number 30. So number 10, we have the opposite signs since we're subtraction, so I want to change all the signs. So make this a plus. Wow, that is a terrible plus. There we go. Plus, plus, plus. They were all negatives, so that just turned out to be decent for us. So looking at the highest degree, we have a 5 on our first polynomial. So we got negative 6n to the 5th. Let's see if we have a 5th or anything higher. We do. So we have a positive 8n to the 5th. So negative 6 plus 8 is going to be a positive 2n to the 5th. We have a 4th. So negative 8n to the 4th plus 6n to the 4th is going to be negative 2n to the 4th. So I'm going to cross these off as we're doing them. I know that makes this a little bit more messier. I'm sorry. The next thing we don't have a n squared, so then we have a positive 3n. And then we have just a positive 3. So if I was to label that, or to name that, that would be a 5th degree four-term polynomial. And hopefully the naming is getting a little bit easier. I know it's new stuff, y'all, so it's a little different, and you're having to remember those words. But the monomial, binomial, and trinomial are just focus on the prefixes there. So like mono, bi, tri, those will help you remember how many terms are there. All right, I'm gonna scooch over to number 30. And I'm gonna make this just a little bit smaller in there because I'm gonna deal with zooming in. Okay. So since we're just adding on this left portion of it, I don't have to change the sign, but we are subtracting, so I'm going to go ahead and change those signs. So I'm going to make this a plus, this a negative, and make this a negative. Okay, so this is now just a negative. So then we're going to group everything together. Looking at the highest degree, so x to the fourth, y to the fourth, this degree would be a degree of 8 because it's 4 plus 4. You want the amount of total exponent powers that are together on the monomial, so this would be 4 plus 4, which is 8. But we have x to the fourth, y to the fourth, and we have another one here and another one here. So I'm going to underline those real quick. So we have negative 7, positive 4, negative 6. So I'm going to write those real quick. And this is a lengthy problem, so don't freak out just because you don't understand. This is more of an involved one, and you won't be asked something like this on the so the mastery assignment, the Google form that's at the bottom. There's going to be one that's a bonus question. I think that's number 4 that has 3 trinomials, but it won't be as intense as this. I'm pretty sure it has something. It's just no more than like x squared, y squared type of situation. You won't have this as intense of degree. All right, so then our next degree is x to the fourth, y to the third. That'd be a degree of 7. So we have here, nothing in the first one. We have one here and then one here. So I'm going to put those together. So negative 10 x to the fourth, y to the third, minus, I know it's really tiny, but I changed that sign there. X to the fourth, y to the third. So these are good. I'm going to double underline those. Now I got those. And then the last thing you have is y to the third, y to the third. So we're going to triple underline those to know that I'm done. So I got plus y to the third plus 6y to the third. All right, and then just combine. So negative 7 plus 4 is negative 3x to the fourth, y to the fourth. Negative, oh, whoops, you know what I forgot? I forgot this negative 6 down here too, so I need to erase that because Mr. Parker made a mistake. All right, let's try that again. So negative 7 plus 4 minus 6. Negative 7 and negative 6 makes negative 13, plus the 4 is going to make negative 9. You could have also had this as negative 7 plus 4, which gives us negative 3. Negative 3 minus 6 is negative 9. It's another way you could have added those or combined those. Negative 10 minus 1 is going to be negative 11. And then y to the third plus 6y to the third is going to be plus 7y to the third. So if I was to label this, which I would not ask you to do, I think is intense in this, something as crazy as this, because this is going to be a high degree. Our highest degree is going to be as we said before, is going to be a degree of 8. So this is going to be an 8th degree. And then how many terms do we have? We have 1, 2, 3, so an 8th degree trinomial. But again, you didn't have to label it. I'm just added this to it and ask for y'all to do that. I'm adding this to that. So that's just another thing you can do. If you have more questions on the guided practice, please ask them. But I'm going to ask for you to pause on asking those until tomorrow. If you could, please pay attention. I'm going to make the announcement probably in the morning. I have a meeting at 10, so it will probably be an afternoon stream as well. And like I said earlier, there may be times where I have to pause just for a second because of there's a call center situation going on where we're having to answer other questions. So don't take offense if I have to pause for a second. I will, it'll be briefly, and then I'll edit that out at least when I make the final edits for that. So if you have more questions, write them down and make sure you don't forget, and we can ask those again tomorrow. And it will probably be around the same time. I'll probably be closer to 1:30. And then also, if you'd like, I made a mention as well, PBS, the PBS channel is doing, I guess, reviews, and I don't know, have a whole lot of knowledge of this, but they are doing, I think between 2 and 3, they're doing review for science and algebra topics. So if you happen to miss the stream, that's another option as well. And I'll try to at least do the stream around those, so you won't, if you want to still watch those and miss this and visit this, then that's fine as well. But I'll have a more definitive schedule starting next week. I know it's a little wonky right now. I miss you all a ton. I'm gonna switch to pre-algebra now, so if for algebra, if you want to come back tomorrow, that's cool. If you want to hang around and review on volume, that's fine as well. I'm going to back out for a second. I'm just going to go get some more water, and then I will be back. So I'm not ending it. I'm just going to be right back in just a second. Alright, y'all, I am back for pre-algebra. Thank you for being patient. I'm gonna just switch over this stuff, so none of this is gonna make sense right now, so I'm switching over to a different whiteboard. So I'm gonna kind of explain stuff over as well, what I explained for algebra. So to kind of go over everything that was going on with, oh, whoops, I just backed out of that. That's not what I wanted. So just give me 1 second to bring it back up. So every week you're going to be given kind of like a syllabus, and on this syllabus is going to be all the material that you need to know of what to do that week. You're only going to be given that assignment that week. So these are materials that you'll need. This is going to be like the review stuff. So part 1 is like the review stuff, and then part 2 is going to be the new stuff. You'll have videos, keys to the notes. I'm going to kind of go over the notes today as well. Some practice, which I have IXL pulled up so we can work on some practice problems as well, because I didn't have a whole lot of guided practice, so I'm sorry about that. And then there's also some videos on the next part, because this was kind of a heavy unit. So I'm going to kind of go over I'm just going to go over just straight volume and surface area today, and then on the changing attributes, I'll do that tomorrow. So this is going to be a little bit shorter of a video, but I will have more stuff to go over tomorrow instead of just going over just more guided practice. And like I said, you have the whole week. You can contact me with questions or anything, and hopefully these are helping. If you are here or not here, you could still watch them later, even if you're not here. Hey, Carter. So I just finished up with algebra. I was doing pre-algebra next. If you start it back over, I went through the notes and some practice problems. And if you want to, and then I'm going to do another stream tomorrow to do some more of the practice problems. But if you have any questions, just make sure to write them down and I will gladly go over them. I could even answer your email, but I feel like in person would, well, quote unquote in person, I mean like kind of in person, would help as well. But I'm going to go over polynomials with algebra tomorrow. So I will, but I'm going to do volume and surface area right now. All right, so to go into volume and surface area. Sorry, bud. So like I said, this was an impromptu one. So I'm sorry that you missed some of it. But like I said, if you just scroll to the beginning and then you have questions, you can come back and ask me as well, and I can answer those as I go back and forth. So with volume, let me switch one thing on here. Volume and surface area kind of go hand in hand. Volume is dealing with how much an object can hold, can contain. So think of like the amount that's in a soda bottle, or the amount that you can fill into a present. And then surface area is like how much you can wrap around, like the wrapping paper around the present, how much you have to paint, that type of situation. So I'm going to go over the and the nice thing about surface area and volume is that you're given the formulas on your formula sheet, which I mistakenly not added into this thing, so I am sorry, but luckily they're here on the notes, with the exception of the surface area ones. So I'll have to go and grab those if we do some surface area problems, which I think I might just save that for tomorrow since I made that mistake. I'm sorry. This is kind of impromptu, like I said. Volume of a pyramid is kind of like a volume of the rectangular prism. So volume of a rectangular prism, so like a box. So this is going to be a really terrible box for me to draw, so I'm sorry. So when you had something like this, you had your height, you had your length, and you had your width, or this could be the length and this could be the width. It didn't really matter, or flip them around for the dimensions as long as you labeled them. But you multiplied all these and then you got the volume of that. Well, this time we're dealing with the same type of concept, except we have it where it kind of closes in. It has this taper to make this pyramid, except with this type of volume problem, the most common mistake is this variable right here. That is a big B, and that big B is the base area, or the area of the base. The area of the base. And so you're going to have to do two different things. You're either going to have to find the area of a rectangle. They'll tell you it's a rectangular base, or you'll see that's a rectangular base because the area, the lengths are different on each side on the bottom, or a square base where they'll only give you one dimension, so it's to assume that it's a square. So if you have a square base and you have to find the area of the base, you're going to do area of a square, which is s squared. And then if you have to do the area of a rectangle, so this is a square. Then if you have the area of a rectangle, the area of a rectangle, remember, is length times width, so you'll do the length times width, then we'll multiply by the height, and then either divide by 3 or multiply by 1/3. So that's the volume of a pyramid. Volume of a cone, you will not see this exact formula on your formula sheet. You'll actually see it with the base area already written out for you, because the area of the base is a circle. So if we wanted to find the area of that base of a circle, the area of a base is pi r squared. That's the area of a circle. And then we're going to write the 1/3. And then the height. So this is what you would see. Okay, and it's the same concept though, because we're just looking at the base dimension, the base area, multiplying it by the height, and then we're using this scale factor of 1/3 because it's not a full cylinder. If it was a full cylinder, then we wouldn't even bother with this, but since it tapers, it decreases, it gets closer and closer to a point, then we're losing some of that original volume if it had been an entire cylinder or an entire rectangular prism. So that's why that 1/3 is there. All right, so and again, I know a lot of this has already been filled out for you if you have the key. I just felt like going through this would help out a little bit. So sometimes it's better to hear it rather than just read it. So, and if you have questions, again, I've already done algebra. If you're here for algebra, I'm sorry. If you just scroll back to the beginning, algebra, I went over that, and then just know that I am going to stream tomorrow, and then for pre-algebra, we're just going to be going over some practice problems of the notes that are already there, and feel free to ask questions if you're from either class, pre-algebra or algebra, and I'll answer as I can. Okay. So with this one, they said find the volume of the square pyramid. They even told you it's a square-based pyramid. Okay, and so we're going to have to find the area of that base, and they want to know the, they want to know the volume of this square-based pyramid to the nearest cubic foot. So the first thing I want you to do is to find the area of that base. That base is a square, so that means it's going to be, and I'm really sorry, I'm going to try my best to write this S. It's an S squared. And we're going to substitute in what for S? We're going to substitute our side length. So it's a side length of 8. So I'm going to put in 8 squared, because I put 8 in for S. And when I do that, I'm then going to square 8. So 8 squared is going to be 64. So that's the area of our base. So we got that done. That's the first part. Now we're going to get to our second part. So now we're going to plug in our B. We know our H, it's 10, and we know 1/3, so we're good to go. So we're going to substitute in 64 in for B, 10 in for H, and then multiply. So 64 times 10 is going to be 640, and this is where you can do one of two things. And I need to pull up Desmos real quick to show you the Desmos. So with Desmos, you can do one of two things. I would recommend doing 1 divided by 3, then going over and pressing multiply. Notice, do not leave your cursor in the bottom like I did here with the denominator. Click the right arrow or click over here to move the cursor. You're then going to do times the area of the base was 64 times the height, and you're good to go. You have your answer as 213.3 repeating. I'm going to draw the line over the 3. Now, if you had not done it that way, you could have also instead at the end, press enter after you multiply it, and then do the answer button divided by 3. That's another thing you can do as well. The other thing you can do, which is another common thing since Desmos is so nice with inputting variables, you can save variables. So we found the area of our base to be 64. They told us the height was 10. Then we can write our formula as 1/3 big B, little h, and it gives us the same answer. You don't even need to do the multiply buttons. The one thing I will say about this is uppercase and lowercase do matter. So I saved lowercase h as 10. If I put a big uppercase h, or an uppercase, I'm sorry, if I put an uppercase h, it's not there. They don't know that. This calculator is good at doing math, but it doesn't know this variable is what's called not defined. It's not defined. We didn't put that in. So you want to make sure you use the appropriate, it's case sensitive, like the appropriate case when you're putting that in. So if we were to round this to the nearest cubic foot, it's 213.3. So that 0.3 is under 5. So we're going to keep it the same. We're going to just technically round it down to the where it originally was. So 213 square feet would be our answer. All right, so move to the next one. I'm going to do the volume of a cone.
You're fine. No, you're fine. Kelly was just asking for the payroll. It's fine.
Sorry, one second, y'all.
Thank you.
Later. Okay, so where was I at? I am at now the volume of the cone. I'm trying to see if y'all can see this. No, I need to move over more. Okay. So with the volume of the cone, remember the base shape is a circle. So we kind of already know what the base area is. We can find that out ourselves. So let's set this up. So the base area, remember, is pi r squared because it's a circle. And we're given right now the diameter. So if the diameter is 10, we need to know what the radius is. So the radius is half the diameter. So that's going to be 5. So we're going to substitute 5 in for r. And we're going to square 25. And multiply by pi. So I'm going to clear this out. So we're going to do 3.14 times 5 squared, and we get 78.5 for our base area. I'm sorry if that's really terrible writing. That's 78.5. 78.5 is the base area. And then I'm going to plug that back into our 1/3 base area times height. So 78.5 will go in for big B. And our height was 4. I know it wasn't very easy to see the line, but there's a line that's right here. It's very faint. And I'm not going to lie, I didn't like writing in here, so I'm going to write over here because it was just too cramped. So we have 1/3 78.5 times 4. Now again, you could just plug that straight into the Desmos calculator, or you can label your dimensions and then just put them in that way. So you could have done big B equals, and then while you go to calculate that, you can wait to calculate it. You can put your height is 4, and then 1/3 big B h, and now let's say, oh hey, we now have our big B. We found it to be 78.5. So we get 104.6 repeating. And they want us to round to the nearest cubic centimeter. So rounding to the nearest cubic centimeter, it's 0.6. So we're going to have to round up. So that means then the volume of the cone is going to be 105 cubic centimeters. Okay, so now We were given two example problems. We have a square base pyramid, and then we have a cone. So I'm going to do number one, the square base pyramid first. So we need to find, the first thing we need to do is find the base area. And in fact, I'm going to kind of write it over here because I don't like how cramped everything is over there. So I'll write my final answer over there. So this is going to be number one. I'm going to write that over here, number one. So the first thing we need to do is we need to find the base area. And the base shape is a square, which they told us. So to find the area of the square, and I should just go ahead and make that big B because, so the area of that base is going to be S squared. And the side length is 30, so that's going to be 30 squared. So big B is going to equal 900. So that's our first part. We're not done yet. Now we need to find the volume. Since I found the base area over here, I'm going to go ahead and write in the volume below. So to find the volume, it's going to be 1/3 big B height. So 1/3 times the 900, which was our base area, times the height, which was 64. If I plug that into Desmos, so 1 divided by 3 times 900 times 64, I get 19,200 cubic inches. So I'm just going to write my answer over here. So that's going to be volume equals 19,200 cubic inches. Alright, and then we're going to do the last one, and then I'll probably do one more practice problem if someone has a question for it, but if not, then I'll hold off and I'll do some more tomorrow. Alright, so now we're dealing with a cone. So I'm going to do number 2 below here. I'm going to do this in purple. So number 2, we need to find, let's change the, so we need to find the base area, and this time it's a circle. So the base area is going to be pi r squared, and the radius they actually gave us already, so we're good. So that's going to be 3.14 times 3 squared, and we'll find our base area to equal, that is just a terrible B, so I'm going to scroll up to see if that helps my handwriting. So if I was to put that into Desmos, oh, whoops, I'm in the wrong window. So we get 28.26, and it's best to go ahead and just use 3.14 for pi. I know there's a pi button in here as well, but I would recommend just using 3.14 because otherwise your numbers are going to be quite lengthy. So I'm going to write the base area as 28.26. So I have found the base area, but I'm not done yet, so I need to now do the volume. So the volume I'm going to write underneath here, it's getting a little cramped, so I'm going to write the volume. And to find the volume, it's going to be 1/3 base area times height. So 1/3 times the base area, so 28.26, times the height, which is 12. And again, you would just put that into Desmos. So whoops, wrong button. So if you didn't want to define your variables, you can write it as this as well. So then we found our volume to be 113.04 cubic meters. Now the thing about this though, they wanted to the nearest cubic meter, so we're not done yet. So we were going to round this to the nearest cubic meter, which it's 0.04, so we're going to round down, or stay the same, I guess is a better way to say it. So 113 cubic meters would be our final answer. So volume equals 113 cubic meters. And let me get rid of that calculator so you can see. So that would be our final answer for that. Might not be able to see that, so I'll write it up here and see if that works better. See. So I was gonna do a few problems in IXL unless anybody has any other questions about this stuff or. And feel free to ask questions, like I said. I'm going to move this though so I have more space to work out the problems. So let's see, I'm gonna write over here. And what I'm gonna do is, let me just make sure, yeah, that'll be good. So I'm going to put it up so you can see it. I'm gonna have to write the problem down. I'm sorry, I should have brought this up earlier. That's my fault. I was working with. So the optional practice was guided practice for the volume of the cones. However, I am going to do a volume of cubes, prisms, and pyramids. I'm hoping that I can skip some of them because there are going to be some triangular prisms and some triangular based pyramids, which you don't need to do, but I still like to practice with it, so we're going to try. And I'm going to skip these because these are review. So with a cubic or rectangular prism, you would just multiply the length, width, and height to get the volume. So 10 times 10 times 10. So that would be 1,000. I'm going to skip this because you don't have to know how to find the volume of a triangular prism. Of course, we got another time. Well, I guess it proved me wrong. So I'm going to just do cones, I guess, for right now, and we'll do surface area of cones to kind of go with that. And if you have questions, feel free to ask in the chat as well about anything that I've gone over. You have questions on, and you're gonna have to bear with me for a second because I'm gonna have to flip back and forth to write the question down as we're doing this. So we're given a cone. They're asking for the volume. They gave us 2 dimensions. They gave us the height of the cone and the radius of the cone, and they want it to the nearest to the nearest hundredth cubic yard. So I'm going to write these dimensions down as height and radius. So radius of 6, height of 10. Okay, and then for the cone and the square and rectangular base pyramid, it was best to just use the 1/3 base area times height, so you don't have to remember 2, 1 for cone, 1 for pyramid. You could just keep them the same. You can if you want. You don't have to memorize them because they are on your formula sheet, but just as a heads up, it's better to remember 1 rather than 2 different ones. So we're going to do the volume. So let's find the base area first. And I left the problem up for y'all to see. I can't see it, but just to reference that question as we're going over this, and hopefully you can, yeah, just need to move up some. Probably move over. So the base area of the shape is a circle. So the area of a circle is going to be pi r squared. So the radius, luckily enough, they gave to us, which was 6. So 3.144 pi. And the radius is 6. So I'm going to plug that in. And then I'm going to simplify to find out it's going to be 36 times 3.14 because 6 squared is 36. So I need to bring up Desmos. So the problem's going to go to Desmos for a second. So 3.14 times 6 squared, and if you forget the squared buttons right here, you can also do the little caret symbol on your keyboard and then put the 2 in. So they found it to be 113.04. And I'm just going to press enter for right now. So I'm going to write that down, 113.04, 113.04, but we're not done yet. So we have the base area. So now we need to plug it back into the volume equation. So I'm going to scroll down, but just remember that the height is 10. Actually, can I zoom out? Maybe that's going to be better. So if I was to write the volume now, base area times height, the base area we just found was to be 113.04. Don't forget the 1/3, and the height was 10. So we're going to multiply those all together. So what's nice about Desmos is you notice that I pressed enter this time, and we have our answer for our base area up here. So if you press this answer button, it puts in the last answer you got, which was our base area. And then you can just then do multiply by 10, and you get your answer of 376.8. So 376.8 cubic centimeters. Is that what we're at? Let's see. Oh, I'm sorry, cubic yards. Cubic yards. And they want it to the nearest hundredth. So the nearest hundredth is the second decimal place. So in this case, we already have it to the nearest tenth. So I'm just going to leave it as that. So I'm going to go ahead and type that in as 376.8 and then press submit, and we're good to go. I'm going to do 2 more problems. So I'm going to erase this board real quick. Right. This time though, you need to pay attention to the dimensions because this time they didn't give you the radius, they gave you the diameter. And how do you know that? You know that because the line goes from edge to edge and cuts through the center. So I'm going to write out my dimensions real quick. So that's my diameter. So a diameter, so the D is going to stand for is going to be of 10. And I'm sorry, I'm going to have to go back to that. I have to click on my screen, not yours. A height of 8. And I'm going to put the meters just for my sake that I know that I'm dealing with meters. And the other thing is that we're not going to deal with diameter when we're doing volume. We need to deal with radius. So we have to calculate that real quick. So I know the radius is half the diameter. So half of that is going to be 5. All right, and then I'm going to keep going. So I need to find, I want to know the volume, but I need to know what this base area is first. So let's find the base area. And the base is a circle, so that's going to be pi r squared will give me my base area. And I know we usually use A for area, but since we're dealing with volume right now, I'm concerned about the base area. I'm going to write big B. And then I'm going to plug in what I know. I know pi is 3.14. And my radius is 5. And then I'm going to plug that into my calculator. So 3.14 times 5 squared, you get 78.5. So I'm going to write that down. That's an equal sign, I'm sorry. And that's meters squared. And you don't have to write the meters squared again. We know it's area, so that's why the meters are squared, and we're going to multiply it by one more dimension, which gives us our third dimension. That's why it becomes a 3D shape when we're dealing with volume. So volume is going to be 1/3 times the base area times the height. So 1/3 times 78.5. And the height I wrote up at the top was 8. And then again, I'm just going to throw that into Desmos. I'm going to press enter so I can save my answer. You could also have labeled this as B if you wanted to, big B, and then labeled your H, and then just plug that in. It's up to you. And again, you can press answer. You could also type it in. It's up to you. If you have like these long decimals, I would recommend using answer. So you make sure that you include the entire thing. And then times 8. So our answer is 209.33 repeating. So our volume. So I'm going to write this as this. However, they want it to the nearest hundredth. So if I was to put this in, it would be 209.3 would be to the nearest tenth. One more time is the nearest hundredth. And there would be continuing to be 3, 3, 3, 3, 3, 3. So since it's below 4 or below, we keep it the same. So 209.33 would be our final answer to put into Desmos. Just to see, kind of want to do another one that's a little bit more difficult or further, but I'll stick with this level for right now, and then I can do some surface area tomorrow. And then on Thursday, I'll go over changing attributes because like I said, this is kind of a lengthy, it's a lot to cover in such a short amount of time. So, all right, I'm going to clear this. And I'm going to go back just to write those dimensions. And so again, you're going to pay attention to what they label. They labeled this time the diameter again, and you know that because it goes completely across through the center. So you have a diameter of 12 and a height of 13. So that means then we have a radius of half that, which is 6. They want us to find the volume. So we need to do find the base area first. The base is a circle, so our base area is going to be pi r squared. So that's going to be 3.14 times 6 squared. 3.14 times 36. So clear all this. 113.04, and I know I said times 36, but that's just because 6 times 6, or 6 squared is 36, so you can also put it in as there as well. So 113.04 is going to be our base area. And then we're going to put it into our volume equation. So volume equals 1/3 base area times height. So we have 1/3 times 113.04 times the height, which was 13. So multiply straight across. So I'm going to press enter again just so I can use the answer. Again, you don't have to do it this way. You can just type it in just as it is. And in fact, I'll just go ahead and do it this time like that. 13.04 times 13. And we get 489.84 cubic units. So our volume what did I just say? I'm sorry. 489. So that would be our 489.84. Yeah, cubic meters. And luckily enough for us, it is to the nearest hundredth because it's the second decimal place. So we can just enter that in just as is. We don't have to worry about rounding. So I'm going to submit. And we're good to go. I'm going to stop there unless anybody has any questions. I'll give you all a few minutes just to ask questions if you have any. I will go over surface area tomorrow. I know the videos were mainly on volume, but surface area kind of goes hand in hand where you're just putting in the values of the dimensions and then just simplifying. And then on Thursday, we'll go over changing attributes, so changing the dimensions and how it affects surface area and volume. But if anybody has any quick questions before we go, I'll answer those real quick. All right. If nobody else has any questions, I will see y'all tomorrow. I miss y'all a lot. Take care and stay safe. And like I said, if you just want to email me any questions too, you can do that as well. Um, but I will be here tomorrow live streaming. I'll let you know in the morning. I'll post that in Google Classroom. And again, in Google Classroom, I'll let you know if algebra will be first or pre-algebra. It may just flip-flop every once in a while. So just be patient as we're getting the schedule worked out. But again, I miss y'all. I'll talk to you soon. And have a good rest of the day.